Welcome to this video calculating rate constants from initial rates data. And we're going to want to calculate the values of the rate constants and also the units. I'm going to explain how to do that. Okay, so from these initial rates data, this is the same as in the last video. Watch that if you're interested in finding out the orders of reaction. But now we've got those orders, we can simply sub in any of these rows of values. Now remember, if you've done them relative to the first row, you now need to use the actual numbers to work out K, simply by rearranging this formula. So why don't you have a go at doing that? Pause the video and rearrange it to make K the subject. So you should have got the following. So K is equal to rate divided by concentration of A to the 0. So essentially we can forget the concentration of A times concentration of B squared times the concentration of C. And if you want to calculate K, all you need to do is sub some numbers into this from any of the rows and you find the answer. So I'll just use the first row, so 0.001087 divided by B squared, which is 0.15. You can use, of course, initial concentrations because they're just examples of concentrations, so anything should work. This should hold for any combination of concentrations. And rate. So when you plug that into a calculator, you come out with an answer of 0.230 to 3 significant figures. And probably should only give this to 2 significant figures because we've only got 2 significant figures there. So there's the answer we've got. So now we want to put a unit on that, and so we can use, so I explained a slightly different way in a previous video how to find the units, but here we can use the fact that units behave in exactly the same way as algebraic symbols. And if we've got a formula for K, then in the units world we can simply substitute in the units for these instead of the actual values, and manipulate the units just like we would any other algebraic symbols. So if we say the units of K here, so I'll just put a little curly brackets around that. So units of K is going to be whatever the units of rate are, and that's mole per decimeter cubed per second. I've just simplified it here, just writing mole per decimeter cubed by the molarity symbol, but we should put the full units in now. So mole per decimeter cubed squared for the B's, and for the concentration of C, that's just going to be mole per decimeter cubed. So now we just need to use a little bit of index laws in order to be able to figure this out. So on the top we've got mole dm to minus 3 per second staying the same, but now we need to combine these. So mole to the power 2 is going to be mole squared multiplied by another mole, you're going to get mole cubed. Decimeters to the minus 3 squared, you multiply the indices, so that's decimeters to the minus 6. But then you've also got multiplying that by decimeters to the minus 3, so you need to add the indices. So overall you've got decimeters to the minus 9. And then, so that's all you're going to end up with on the bottom. So effectively got mole per decimeters cubed, cubed. Now we need to do a little bit of cancelling. So we've essentially got mole to the 1. We're dividing, so we need to subtract the indices. So we're going to get mole to the minus 2. I'll just shorten this line for clarity. So we get mole to the minus 2. Again, we subtract the indices. Minus 3 minus minus 9 is plus 6. Decimeters to the 6. And seconds to the minus 1. Usually we quote the positive indices first, so that would be decimeters to the 6. Mole to the minus 2. Seconds to the minus 1.